welcome to thlympic. So we are together again with another 4 questions from social media. So let's start. So this is our first question. We have an equilateral triangle and some side relations are given. Question ask area of the triangle. So for equilateral triangle, all sides have equal lengths. So we can equalize these two expressions because they are equal in size. So the y's canceled, we got x is 3. So first, if you want, you can substitute 3. And the second one, let's write another equation to solve for y. So these two are equal. We already know x is 3, so 2x is 6. And if you move 2y there, so it will be 3y, and let's take 3 here. So 3 equals 3y, y equals 1. So if x is 3 and y is 1, the one side equals 4. So all of them 4. So you can check. If you write 1, 1 plus 3, 4. This is 2, this is 1. So again, x is 3, 1. So again, we got 4. So the all side lengths 4. So we have this equilateral triangle with all sides 4. To find its area, we can draw a height. So height divides into 2 equal parts. It means these are 2 and 2, and this is 30 degrees. So you can use Pythagoras theorem to find this, or if you know the relation between 30, 60, 90 degree triangles. So this is root 3 times this one. So this is opposite 60 and this is opposite 30. So this is 2 root 3. Now to find area, we use area formula, height times base divided by 2. Height is 2 root 3, base is 4. So let's multiply them and divide by 2. So these two cancel out. So we left with 2 here, 2 times 2, 4 root 3. And this is simplifying square roots, but this is not clear that it is square root or not, just we will find it. So it's a different question. So what we can do is, let's start from inside. So the degree of square root is 2, and if a number doesn't have power, it is 1. And to change it in this form, we do like this, the power divided by degree. So instead of this, we can write this one. This is step 1. Step 2, again, we follow the same step for this part. So you see here, this is power of inside number and this is degree of the root. So we divide this by x, or we can write in this form, the power divided by 1 over x. So in this case, we consider this as just one number with power 1. So if there are 2 powers, we multiply them. So if we multiply 1 over 2 by 1 over x, we will get 1 over 2x. So we replace this instead of this one. So now we got much simpler, and we have one more square root to deal with. Again, we use the same rule. Consider this as a one number with degree 1. So we can write this as this power 1 over 2. And since we have 2 powers here, we multiply them. So 1 over 4x. And again, we have another power. We multiply by that one, 2, 8, and 4 simplified. So 2 over x left. So 3 power 2 over x equals 3 power 1. So this 3 has power 1 here. And if bases are same, powers must be same. So we set our equation. We can do cross product. So x equals 2. So it means this is also a square root. So our third question is again from simple math. So inside an equilateral triangle, a square is inserted. Area squared is 9. So it means each side is 3, 3, 3. So since this is equilateral triangle, we can first write these 60 degrees. And since this is a square, these are 90 degrees, 90, 90, 90. So if this is 90, 60, it means these are 30 degrees, 30, 90. So again, this is 60, 60. So we have another equilateral triangle here. So if this is 3, this is 3, this is 3, and this is 3, 3. We already mentioned them. And this 3 is opposite 60. So using the spatial triangle 30, 60, 90 degree right triangle. So the opposite 60 is root 3 times opposite 30. So what number times root 3 is 3, which is root 3, and hypotenuse is twice this side, so this is 2 root 3. So if you don't know these relations, you can check from internet. So right triangle with 30, 60, 90 degrees. So in this way, we got all the side lengths. So this equals 3 plus 2 root 3. And same thing you can see here, 3 plus 1, 2 root 3, and 3 plus 2 root 3. So the question is area of this triangle. So we need to find its height. Up to here it is 3, and this is, so we calculate it here, because if you form the same triangle, the opposite 30 is half of this, so 1.5 or 3 over 2, and this is root 3 times. So this is 3 over 2 times root 3, this height, and this is 3. So the total height is 3 plus 3 over 2 root 3. And if we simplify it to make a single fraction, so it is 6 plus 3 root 3 over 2. And side length is, we mentioned 3 plus 2 root 3, or same as here. So this is the base and this is the height. So let's calculate the area. Area equals 1 over 2 times, height times base. So this is height, this is base. So these two we can multiply together, and we can multiply these brackets together. 18, 12 root 3, 9 root 3, and 6 times 3, 18. So we got this one. And we can simplify these two, 21 root 3, and these two, 36. And we can remove the bracket by multiplying each term by 1 over 4. So if we multiply these two, we can simplify and get 9. And if we multiply these two, 21 over 4 times root 3. So that is the area of the big triangle. EF, 1 minute, what's question? Yes, EFG, the big triangle. Okay, this is the final question. Oh, I forget the name of this. Okay, this is a kind of puzzle, but it is not easy to solve with normal math or without calculator. So we need calculator for this, according to my calculation. So what is given is this big circle has radius 8, and this rope has length 12. So longer than the radius, but shorter than diameter, because if radius is 8, diameter will be 16. So if this is, let's say, 12, it can graze around this area. So let's say this is the full length of the rope. So it will make a circle around it. If the horse can turn around this with radius 12. So here also radius 12. This is also radius 12. And since the radius of inner circle is 8, so this is also 8, this is also 8. And if this is 12 and the full is 16, so this is 4 and this is 4. Right now what we have, let's check carefully. So here we have isosceles triangle. This is 8, 8, alpha, alpha, if we call this alpha. And these two will be same because this is the middle, and everything same for these two triangles. So alpha, alpha. So this length is 12, here also 12. If we draw this line 90 degree, since this is isosceles, this is 8, this is 6. And so using Pythagoras theorem, we can get this one. Also in this triangle, if we draw AB, this straight line, if you check this triangle, it is similar to this triangle because alpha 90 beta, alpha 90, this will be beta. So using this similarity, so this is 12 and this is 8. So opposite alpha is here 2 root 7. So we will get 3 root 7 because the ratio is, if this is 8, this is 12, so ratio is 2 to 3. When you simplify by 4, you will get 2 here, you will get 3 here, so 2 to 3. So if this is 2 root 7, this is 3 root 7, this part. And again, using Pythagoras theorem, if this is 3 root 7, this is 8, so we get this as 1. If this is 1, total was 4, so we get 3 here. So in this way, we get all these calculations. Now the question is, what is this area? How to find it? So to find that area, remember this is a sector. Did you see this? So this is just the sector of the big circle. So if we know what is this angle, alpha or 2 alpha, so we can just use area formula for the sector area. So pi r squared times 2 alpha over 360. So here AOC, what's AOC? O is the center, C, this area. So this area you can easily calculate because everything given. We know base, we know height, and area AOC, this is sector, sorry, this is sector. So this one. So for sector, we need this angle, 2B. So for finding angle, I think there is no easy way. We need to use calculator. So inverse sine formula. Since sine alpha is 2 root 7 divided by 8, and if we simplify these two, we will get this one, sine alpha. So using this, we can get alpha, sine inverse formula, alpha equals sine inverse root 7 over 4. So I didn't find that much because I don't have much space, but this is the way. So using calculator, you can find alpha. So if you find alpha, you can find this area. And so here the formula, you can use it. Pi r squared for the big circle, 2 alpha divided by 360. So we got this. And we also need these two. So to find these two, from sector, we subtract this triangle. So the area triangle is easy. Here we calculate it. ABC. Oh, this is the big one. So we calculate this one. But likewise, you can calculate this one. It's easy. So just subtract this triangle from this sector. If you know alpha, you will get beta 2. So you can find what is this 2 beta, and you can find this sector. So it will be a decimal number because we will use calculator to find angle. I don't think it's an integer value. So thank you very much. See you in next video.